All right, I'm gonna start talking. So hi everyone, like I mentioned, my name is Sue. Thank you so much for taking the time to utilize the seats and also maybe learn a little bit more about what we at Artisense do. To start it off again, Artisense is a spin-off from the Technical University of Munich. This happened in 2018. Yeah, and I'll also share a bit more information about our company later on. So to start things off, Elon Musk, someone everyone knows, has been saying that in 2014 we will see a 90% capable autopilot Tesla car. He said that also in 2016, 2019, 2020, and also obviously recently as well. And while the COVID pandemic has shown us that there is a need for automation and there is a need for robotics to help us in certain tasks, other than the vacuum robots that we have in our homes, we are still very far away from the reality of enjoying a delivery robot or even a self-driving car. And why is that? Well, to put it very simply, it is a very, very challenging problem. When we want to focus on one particular piece of the puzzle, which is the positioning aspect, so how does a robot or car understand where it is in its space, which is then needed for it to get to from A to B by itself, that is very, very difficult. So you have like traditional alternatives such as ultra-wideband, which people use in their warehouses today. The thing with ultra-wideband is that you need to implement it within your warehouse, and that is not usually something that customers or maybe your clients would want to do. And not to mention that every tag that you implement within your warehouse as well will cost you additional money. And before I worked in this space, my idea of localization and being able to understand where I am in my space is using GPS or Google Maps. But as we know, when we use Google Maps, that doesn't always work in every scenario. So if we're driving in a car, when we go in a tunnel, yeah, that's when we're left alone. Google Maps doesn't help us, and we have to figure out which exit to take by ourselves, right? And that is also the case for when you're in a very dense city. So you can imagine if you're in an area with lots of tall buildings. In those scenarios as well, GPS does not work very well. And in certain cases, GPS, in terms of accuracy, you can see a 1 to 5 meter accuracy, which of course, if you're a delivery robot only utilizing GPS, that can prove to be a problem because that's your neighbor that's going to get your food, right? Not you. And it's not an impossible problem. It just takes a lot of money. Tesla, as you know, is very, very well funded. 0.5 billion, and they're still working on this problem. It's very good, but it's still not complete as well. You've also got companies like Neuro, who is also using different sensors, and they're also funded by 1.5 billion, looking at trying to make this positioning solution possible. But not every company has 1.5 billion. I wish we had that amount of money. Not yet, hopefully. And where does that place smaller companies, right? How are they going to find a way to enable their autonomous systems with much less capital than these other companies? It's for this very reason that Artisense was created, by taking inspiration from how we humans understand the space that we are in using our eyes. So using, as you can tell from how you move around your space, as you move towards a certain building, the building gets taller, right? And using that information, you can kind of get a sense of like, okay, this is how much I've moved. And if you can kind of calculate like, oh, okay, it took me 5 minutes to get here, you can kind of infer how fast you are walking as well. Other than that, typically when we go into an area that we're a little bit unfamiliar in, if we see a familiar building, we get a sense again of like, oh, this is somehow related to a place that I have been to before. And using this sort of information, obviously with a lot more maths involved, we have taken that and used camera instead to understand how a robot is moving in the space, how fast it's moving, and yeah, essentially understanding how it's been moving in the environment that is in. So just a little bit more background about Artisense. As I mentioned before, we are a spin-off from the Technical University of Munich. This again happened in 2018. So yeah, we've been around for quite a bit of time since then. In terms of our linkages to TUM today, we still have our co-founder, Professor Daniel Kramers, who is the co-founder of Artisense, and he is still the current chair of artificial intelligence and computer vision at TUM. So in terms of like getting up to date with the latest developments within the positioning, or as we call it, SLAM industry, yeah, we're pretty good on that part. And what makes Artisense special is that this idea of using camera to understand how you're moving is not really new, but we've developed a novel approach to doing this, which is not typically using features such as corners or maybe certain items in an image, but rather we are looking at the intensity gradients of the pixels in the image that we are seeing. What that means is that typically in more challenging environments, you can think of a parking garage that looks very, very similar, or maybe even a white hallway, which typically cameras have challenges moving down into. That's where we are able to perform a lot better. Yeah, of course, at the end of the day, we're not saying that there are no place for other sensors. Every sensor is great in its unique way. Where we see that we can fit the most is being able to show that with cameras are cheap, they're easy to maintain, a lot cheaper than 2D LiDAR or 3D LiDAR, for example. And we're able to get a lot more information from camera input as well. And of course, the aim is to be able to make the solution or software that we provide as easy for our clients to use. And it's because of this very novel approach that we have that late last year we were actually acquired by a company called Kudan. So Kudan is a Japanese listed company that is also offering their own visual SLAM, so visual positioning software, as well as a 3D LiDAR positioning software too. So today let me move to the next slide. So today with Kudan, we now have offices in, of course, Japan, Munich, which is where Artisense is based, and we also have our R&D in Bristol, and also an office in the US as well. So with Kudan, because they are also offering their own visual SLAM and 3D LiDAR SLAM solutions, essentially we're able to offer our clients a wider variety of positioning solutions based on their applications. So again, coming back to what we offer, it's the visual SLAM. Visual SLAM means using cameras as a way of inferring our position and where we are in space. And for that, we typically recommend our customers to use that in indoor environments. So you can think about autonomous mobile robots, for example, working in a warehouse. Or if you have companies that are looking to build a autonomous forklift, for example, one way for them to understand where their systems are at is using our Visual SLAM solution. And for more complex environments, larger environments, more dynamic environments, that's where we see that 3D LiDAR. Also, our 3D LiDAR SLAM solutions is something that we would recommend. So jumping into a little bit more information about what this camera-based visual SLAM is. As we know, most robots that we see, most of the autonomous robots that we see even here today, will already have a camera in place. It could be because it's being used for other perception tasks, object detection, obstacle avoidance, for example. So it's already, because it's already there, it provides us with a way, or it provides our clients with a way of utilizing the same cameras, but also for positioning, right? And as I mentioned before, cameras, they've been around for a very long time, and a lot cheaper than the other sensors that we see over there, or that we have in the market. And in terms of the information that we can get, it's the richest information that any sensor can provide, because you're not just, you're seeing basically everything in an environment, and you have to pick which information is useful for you. So our Visual Slam, because we are a software focused company, our aim is to allow our customers to utilize any sort of camera that they want, and for us to work with that. So in terms of our compatibility with different camera types, we're able to work with RGBD, stereo, mono, also fisheye lens cameras as well. Oh, I see the formatting of the slides a bit weird. Sorry about that. In terms of then accuracy, of course, accuracy is important. Everyone asks us what's the accuracy that we're able to achieve with this Visual Slam system. And we typically see about 1 to a few centimeters. Of course, at the end of the day, it depends on the application, the space, the environment as well. But in terms of repeatable accuracy, so how well can we make sure that we come back to a certain point? Yeah, it's about the few centimeters range. And like I mentioned, we're not saying camera is the only way. We also have a 3D LiDAR SLAM solution. Our aim is to be able to use the benefits or the best parts of every sensor, which is why we want to be able to fuse in other sensors as well, such as wheel odometry. In the case that like your camera gets blocked, you still want to make sure that your robot can move, right? And you can then use the wheel odometry information to allow that. And also at the same time, let's say if you're if you have a robot that is going multiple floors, that's where fusing the IMU perhaps would be also a good idea. And for certain outdoor applications, we see that also being able to fuse GPS, of course, is if you have it, why not? It's just another sensor that will allow you to get accurate positioning. So here's a quick video. So this video is showing how we're able to operate in an indoor environment. So right now we're outdoors, and this is in a parking garage. And we're soon going to enter into the parking garage. And the point clouds that you see here is not from a laser, it's not from a LiDAR. It is from our camera. And you can see that we're able to get a pretty good point cloud output from our camera-based SLAM solution. And essentially, as you saw that we went through the parking garage, a parking garage is actually very difficult for camera-based SLAM positioning solutions because every level looks very similar. Even us as a human, we get lost, right? So it's kind of hard to expect that a camera might do better, but they are. They are able to do better, and even when you have the changes in the illumination as the system exits the parking garage and goes back in, you can see that we're still able to continue tracking as well. And this is because of that novel approach that I mentioned in terms of not just using corners or specific features in an image, but rather we're looking at the intensity gradients of the pixels, which is then choosing which pixels in an image to continue tracking with. Yeah, so you can see like maybe a little bit later, oh, actually, it ended. Yeah, I'm not sure if you were able to see that we were also able to track the different floors as well. And that was with our fusion together with the IMU. All right. So for the Visual Slam, like I mentioned, focus there is to be used in an indoor environment, specifically for customers that are looking at intralogistics robotics, service robotics, like I think some of the robots that we see over there, as well as cleaning robotics as well. But when it comes to outdoor environments, it's very, very complex. And that's where we see 3D LiDAR SLAM can do a little bit better. Of course, like the aim is to be able to merge as many sensors as possible in the future. So with 3D LiDAR SLAM, the environments are a lot more dynamic, a lot more complex, and also a lot larger, right? So if you're looking to operate as a delivery robot, then this is usually what we recommend to our clients. And in terms of accuracy, of course, accuracy is at the end of the day still something very, very important for our clients. So in terms of what we are able to achieve with this 3D LiDAR SLAM solution, we're able to achieve up to 1 centimeter of accuracy. Again, caveats, depends on the environments, depends on also like the specific applications. With the 3D LiDAR SLAM, again, the fusion is important. We're able to fuse IMU, which I think comes with the certain 3D sensors, 3D LiDAR sensors as well. And at the same time, also fuse in RTK GPS too. So why do we say that 3D LiDAR SLAM is something that we recommend to our clients? It's because we have these two features called map merging and map streaming. The idea with SLAM is that first you want to create a map, and then you want to be able to localize within the map that you previously created, right? But the thing with that after is that once you have a map of a city or a map of an area, it gets very, very big for you to store. And also when you're thinking about the mapping process itself, it can be very, very cumbersome if you have to do one whole area in one day, right? So being able to have this map merging function, which is essentially we are able to split the mapping process across a few days, a few sessions, and we're then able to merge the maps into one combined map, as you see over here. And this, of course, is using the fusion with GPS. And using that GPS information, we're then able to then align the maps and create this larger map. Map streaming is also something that's very interesting for our clients because, again, like I mentioned, when you have a very big map, where are you going to put it, right? And a lot of clients are very particular in terms of storage and also the RAM and compute requirements as well. So with the map streaming, we're able to place the entire map on the server, and then we're able to stream a particular portion of the map that is being utilized at that part. So this is great for very, very large environments because you only are streaming or using the map of the relevant in the area that you're operating in. So again, here's a little video of our LiDAR SLAM. And what you're able to see over here is also a point cloud output, but 3D LiDAR, of course, means it's a bit cleaner, a lot denser, because you're sending out a lot of laser signals to get back this information, right? And this video is essentially showing you that, yes, while we can fuse GPS, we don't always need it. It depends on the client if they think it's necessary. We are able to continue tracking even in an area like as you see here, a tunnel, and able to use that information to understand where we are in a space. All right, let me move to the next one. So what does this mean for our clients, right? So the typical problems that we see our clients face is that, especially when it comes to visual SLAM, it's been around in the industry for quite a while. Maybe not the novel approach that we've developed here at Artisense, but there are open source options available in the market. But the thing with that is that with a lot of open source solutions, it requires a lot of optimization. And essentially, it still requires your team to take a lot of time to do those optimizations, right? And on top of that, it still requires you to put in a lot of effort in order for you to make the positioning solution as robust as possible and able to achieve the precision or accuracy that you need. And that's where the sensor fusion for us becomes essential. And most of the time, when clients start out in a certain environment, so let's say they've developed a AMR for indoor, you see that it takes them a while for them to create a solution for outdoor environments. As you can see, right, a lot of AMRs right now are focusing on indoors right now. It's also because it's when you port your algorithm for indoors to an outdoor environment, it's not so seamless. It would be nice if that was the case, but it requires still a lot of tweaking, a lot more sensor fusion that needs to be done in order for you to operate from an indoor into an outdoor environment too. And this is something that is also close to us. There's just that not many SLAM engineers going around. Not many of us are as heavily funded as the Teslas and the neural companies that I mentioned to you. So for a lot of companies, they might have to build a SLAM or positioning team from scratch. And that's where it does take them a lot more time to get the expertise that they need to push out their product to the market a lot sooner. So essentially for us, we of course want to eradicate all those problems that our clients are facing by enabling a very robust algorithm using, again, the sensor fusion from across different sensors. In terms of what sort of sensors we work with, it's up to our clients, and it's also depending on the environment. Of course, for us, it's having deep and tight collaborations with them to understand what is their exact application, what's the accuracy they need, to then infer what sort of sensors would be beneficial towards that. And at the end of the day, it's making it very, very easy for our customers to integrate with our product. We operate on ROS, and a lot of companies also do that. So we make it very, very easy for them to implement our software into their stack. And in terms of SLAM expertise, there's not that many SLAM companies out there. I think there's only a few other direct competitors that we have. Of course, like every other bigger team might have their own SLAM team within that, but I don't think they will be willing to share their expertise. So for us, it's being able to share our expertise and the knowledge that we've gained throughout the years with our clients as well. And coming to the benefits for our clients, like I mentioned to you, yes, there are open source alternatives which clients can try out, but essentially it still takes time. And we've seen that it can delay a go-to-market for our clients by 6 to 12 months, depending on how complex their environment is, right, and what they're looking to achieve. So we think about 6 to 12 months. We know how well engineers are paid today. That's a lot of money. Right. So in terms of like engineering costs that our clients can save, together with the time that they can save as well, it can lead up to quite a bit. And because of all the optimizations that we have done on our algorithm throughout the years, we know that every client is looking towards being able to operate on a tighter processing requirements. And for what we see, we're able to operate 10 times faster than open source solutions today. And with the open source solutions as well, we've heard that in terms of the speed of the robot that the speed of which your robot is able to operate, there is a limit. And because of the optimizations that we have done, the robot is able to move a bit faster than what they were originally able to do before. And because of that, that means extra productivity and usage for our clients, right? Yeah. And as I mentioned to you, the portability between indoor to outdoor is not so seamless. Because we've already worked on a few projects for both indoor and outdoor, it makes it very fast and more efficient for our clients to push out an outdoor autonomous robot as well. So coming back to the focus areas, like I mentioned, indoor, camera SLAM, that's what we're focusing on. Intralogistics, service robotics, cleaning robots. For 3D LiDAR, we're focusing more on delivery robots. But the bigger vision is actually not just that, right? We see that there is a need for spatial understanding in a lot of different areas, such as AR, VR, also smart city applications, drones, for example. So our greater mission is a lot bigger than the current focus right now. And we are actively working towards that, of course. And this vision is supported by our partners and our clients as well, such as Siemens, Docomo, and Sony, and more as well. So that's the end of my presentation. Like I mentioned to you, we are here. We do have a booth. So in any case that you would like to see our visual SLAM in action, we have it on a very simple robot. We don't sell robots, which is why maybe the robot will look a bit simple later. But it's really just to show you the ability to use camera-based positioning as a way for a robot to continue moving autonomously in its surrounding. So again, thank you so much for sticking around, appreciate it. And in any case that you have questions, I think there is some time. And if I cannot answer them, then my engineers definitely can. So yeah, thank you so much.